Tesla just revealed the AI6 chip, and it could change everything for autonomy, robotics, and AI. Elon calls it a convergence architecture, one chip to handle both training and inference across Tesla's products. A week later, we learned Samsung will build it in Texas and that it's replacing Tesla's famous Dojo system. So what exactly was Dojo? How did its D1 chip work? And why is AI6 such a leap forward? Let's break it all down and see what this means for Tesla's AI future. Phil Beisel was a founding member of the technical team at Rivian, an electric vehicle maker. Before Rivian, he held various engineering management roles at Apple. Welcome, Phil. Thank you for joining me today.
Hello.
Glad that you came. A lot of people have been asking for this to happen ever since the weekend when Elon announced that Dojo is being replaced by this convergence with the inference chip AI6. People were trying to understand, what does this mean? Is this bad news for Tesla? What does the future hold for Tesla? So I wanted you to come in and explain to everybody what AI6 is and what this can look like.
Absolutely.
Okay, let's get started. So you created a deck to explain this. Tell us what you created and what we're going to look at.
Yeah, so I think what we want to talk about is what was Dojo, what was its promise, what did it deliver on, and what did it underdeliver on, and what has been the migration from hardware 3, hardware 4, AI5 to this new chip that Elon announced called AI6, and why what we're really going to talk about is the fact that it's been identified as the convergence architecture for the company, that all inference, all training will happen on this chip in the future, and obviously subsequent versions there too.
Okay. And when are we expecting AI6? Like what year? 2027?
Yeah, I don't know. I think we won't see it until 28 at, first silicon, maybe 28, okay. 29. It's hard to say. I don't think it's super material in the actual instance of having that chip in our hands, but I think what's more material is the larger signal here of where the company is going on a long-term basis. And I think what we're seeing here is Tesla going into its classic playbook of pure vertical integration, right? From chip design and ultimately fabrication of the chip. Like I think, years from now, we'll see Tesla certainly having its own fabs, just like it builds batteries. And that's super exciting. And I think necessary, because I think the reality is that everything in this company is leaning in towards autonomy, everything. And that's all AI. And in some ways, this is more important than battery to the company. And I think that we've seen that signal loud and clear. And that's really the point of this, not so much when the chip materializes. What will happen in the interim is that AI5 will come on strong. It'll be part of Cybercab, certainly in the future, probably 26, late 26, and will be the AI chip, inference chip for all FSD in vehicles and probably all first runs of Optimus. So I don't think we're lacking. I don't think we have a gap here. AI5, I think, is strongly in the pipeline of coming online. And I think Elon has said, and I think I would agree. Well, I would agree. Who am I to disagree? That it's a very strong chip itself. So what we're doing with AI6 is we're progressing that further and really taking it into a deeply vertically integrated kind of way of doing this. Yeah.
Mm-hmm. Okay, let's get going. This is AI6. Thank you for creating this deck, by the way, Phil. This is fantastic. Great deck, by the way. Love it.
Yeah, so AI6 started when Elon announced it or made the first mention in the Tesla Q2 earnings call. And that was July 23rd, and not too many days ago, right? And then he fast followed that with a deal to utilize exclusively a Samsung fabrication plant that's in, I think, Taylor, Texas, close by to, I guess, as he says, his home, at least close by to Austin. And so then what he's saying is, I'm going to lean in and exclusively build this chip at this particular fab with Samsung. And I mean, it's super interesting because it has a lot of interesting components to it in that regard, in that sense that we just talked about. It means that He really believes that this is the next place to truly vertically integrate, much like Panasonic and batteries, Samsung and chips, learn, rinse, wash, repeat, guide them to build it faster, and then probably do it himself at some point. So that's the big news. Now, I did some posts subsequent to that to try to do my level best of explaining what was happening to, overall what was happening here, including Dojo. And then if you see that I was posting something and Elon had responded to it, and he said, once it became clear all paths converged to AI6, I had to shut down Dojo and make some tough personnel choices, as Dojo 2 is now an evolutionary dead end. Dojo 3 arguably lives on in the form of a large number of AI6 SoCs on a single board. So, I mean, the name Dojo, I honestly think the name Dojo is going to kind of disappear, generally speaking, but, he's kind of calling it tacitly Dojo 3. But it's extremely different architecture. It literally takes what was Dojo, which we're about to talk about, away and replaces it with this AI6 model.
Yeah. Thank you for doing that. You actually, I highly recommend people to go to your X account, read what you write, and then Elon, of course, read what you wrote. In fact, he even replied to you this morning too,
yeah.
On a separate post. But this idea of converging of Dojo was a chip that's designed optimized for video training of neural nets, and converging that with a AI series, which is optimized for inference. I've been playing this video clip. I'm not going to do it today because I've shown it in a few shows already. Yeah, Jensen Huang last year basically came out and he said that he sees that inference and training are basically one market. They're converging into one market, and that inference is going to be 1 billion times larger than the training market. It's crazy numbers. But the point was, he himself, obviously a year ago, it's not a surprise to people in the industry. It's a surprise to some of us to realize that there's actually one market. And so Elon saying that we're going to converge Dojo with AI6, it sounds like as if he was put against the wall because his team left. What am I going to do? But actually, this is actually the strategy he would have done regardless if his team, and we don't know because he says here that I had to shut down Dojo. That's his claim. Right. He did it as opposed to, and I would believe what he says rather than, that the team left.
Yeah, I mean, there's no real reason. I mean, the fact is it's immaterial.
Yeah.
Here's, once Elon made the call that AI6 was this convergent architecture, the writing was on the wall. Whether the team decided to leave, who was deeply entrenched in their idea of what Dojo meant and what they were doing, or Elon had to push them out, I just think it's basically irrelevant in the big scheme. It's sort of a headline that you forget a few days later. What lasts is that this new chip, this AI6 chip, marks this point of convergence. And there's really two interesting aspects. Is, to your point, so much is moving to inference. If we think about it, inference is just by the general notion. Let's back up a step and just sort of talk about this briefly. Today, AI is expressed in the form of an architecture called a neural network. And neural networks are asymmetric architectures. They are trained with data, whether it's an LLM, voice recognition, handwriting recognition, FSD, Optimus, whatever. They're all trained with data in a data center traditionally, and then they produce something called a model. And then that model, which becomes read-only at that point, like now it's fixed, given a version, it's all inference. Inference is literally the execution or use of that model. So in your car, it's inference. When you ask a question to an LLM, it's inference. When you speak to an AI assistant and it understands your speech, that's inference. So this use of AI, we're moving vastly from the space of, we trained a bunch of AIs to heavy use across all sorts of things. And so clearly inference takes off and becomes the architecture, or I should say, becomes the winner of the two, whether it's training or inference. And on top of that, what there's another trend that will occur, and we'll largely see that in Optimus, is that Optimus will learn or train on the fly at the edge, and then therefore will, whether you call that training or not, it will be using the so-called inference chip. You know, so this leans further into the space of inference, and so yeah, the number of computations and inference will vastly outnumber those from a pure training cycle.
So,
By the way, they're very similar mathematically. The chips are, and we'll talk about that in a minute in the presentation. There's some differences and some similarities, but there's more similarities than differences between the two. It's not, they are asymmetric in terms of how they're built, but they're not distinct. I mean, both of them feature enormous number of matrix multiply operations, which is this sort of central focus of a parallel processing chip. You know, we've called these things GPUs, and it's an unfortunate term, but GPUs had the first parallel, or what we call accelerated computing architecture, and then they got specialized for, or got utilized, I should say, for things like Bitcoin mining, and ultimately now, you know, AI itself. So so the name really is accelerated computing, and so I think the GPU name, maybe we'll retire that name at some point. I don't know.
yeah. So, but it's what you're saying though is that an inference chip, which is residing on device, can actually do training, and that doesn't actually make sense if you don't use that chip for training. Because this brain is sitting in my brain. Hopefully, I am using it for training. I'm learning things on the fly, not just it's not just the immediate action of if I see something, I know, you know, instinctively what to do and I act. It's acting on previous instructions. No, this thing should be learning, right? And so it can be used for both.
It certainly depends on what the thing is. Like, for example, in FSD, learning on device is much, much less important than, say, Optimus. FSD, in sense, you don't really want your car to learn specific things that another car doesn't, because that breaks a lot of the rules of safety and validation of proper driving. There's certain things you want it to learn, and there's different ways to accomplish that. You know, how to park in your garage, how to go through your gated community entrance, how to, but those are sort of minor things compared to overall what FSD is. And today, when the FSD model is produced, whether it's version 12, version 13, forthcoming 14, that's literally read only in the car. There's no change of that. It's just, inference is just running data through that to, you know, basically photons in, controls out, and nothing is changing in the model. It's just computing through the model. Optimus will see different behaviors there. And I can't say exactly how they'll architect that ultimately. They're starting to use reinforced learning as a model, so that kind of almost leans as a on-device training. And so, you know, it will be different in, say, the Optimus use case. But ultimately, again, these chips have more similarities, whether they're on the training side or inference side, than they have differences. And so one architecture makes sense. I think Elon said something like, it'll make a hell of a inference chip, and it won't be so bad at training too, or I'm paraphrasing it, but that just makes sense.
Okay. Well, thank you for explaining that. That it's very exciting, very important for us to understand this. So let's go through your deck here. Dojo supercomputer.
Yeah. So this is a little bit. I just want to talk a little bit about what Dojo was or is. You know, it was derived from this martial arts term dojo, which is meant a dedicated place to train and hone skills, and that makes sense. Like, it's a dedicated computer for training, and I mean that's basically maybe became its weak spot, is that it was really a training computer and not really a purpose towards inference. It's very special purposed, and we can talk about it from a chip level in a moment. But Dojo isn't just a chip; it's an entire computer architecture, and it's important to kind of separate those two. there's a chip design in itself that's called the D1, or I think possibly it's up to D2 silicon now. And we'll talk. Let's hold off on that. We'll talk a little bit about that in a few slides. But let's talk a little bit about the architecture itself. The idea is that what they did was they wanted something that was really, really fast compute for training large reams of video data, right? And I think, in a sense, and what I mean by that, for full self-driving, right? So the input data for full self-driving is 99% video, and that's also true of Optimus as well. I mean, there's other auxiliary data points, but video data is fat, and because of that, there's a lot of fat, meaning it's large in size, and so in order to send it through these compute structures, you need a lot of bandwidth, bringing that data from storage into the compute fabric through the training side, and then of course, in a sense, back to storage, meaning producing the model. So this whole architecture for Dojo was, they started with a chip design that had various accelerated computing operations in it that are kind of similar to what NVIDIA has in a Hopper or Blackwell, and but then they took an interesting path here, which we'll talk a little bit about, which is they went with a system on wafer design, which is very unique, and that means that they built a grid of these things, a 5x5 grid, and they call it a tile, and they literally cut the whole, instead of having each chip be a unique die and pulled out, they kind of built it in this tile format, and they built these very high-speed interconnects between these chips etched on silicon, right? So instead of just layering the chips on a board and then building the interconnects through some proprietary scheme of data for data transfer, et cetera, they etched it in the silicon itself, and that's very unique. And so with that, then they could take each of those things they would call a tile, and then put them together in a stack, and that very stack they called a cabinet, like 10 tiles high. Then they interconnected these things with some very, very, say, high-speed highways, if you will, to move data. And of course, there's a whole cooling architecture and all this to finally create this specific dedicated training computer, which we have in the picture. And they reached some level of completeness to this. I think I've heard that somewhere between, I don't know, 8 to 10% of the training at Cortex, which is the principal place where the Tesla Gigafactory in Texas, where they have their AI training super cluster for FSD, that about 10% of the workload, give or take, is on their first version of Dojo. So they definitely reached a level of completeness. I think, however, this project started early, and I think it just didn't really get there quick enough. And as we started, as AI advanced and we started to see the lean in more towards inference, it just became very obvious that this thing was going to be a specialized computer. It was built to be a specialized computer, but it would remain a very specialized computer, and seemingly was very difficult to get into production at the levels that was satisfying, the investment. So I think this is Dojo, and I think this is the end of life for this investment.
Yeah, the world changed really quickly, and it took them a little too long to get here, and then it's going to be too hard to maneuver, so we need to do something about it regardless. Okay.
Yep. So this is really a slide that talks about the AIX evolution of chips, and the problem here is that there's been a nomenclature change. We called this hardware 3 initially, then called it hardware 4, and then suddenly it got renamed to AI. So you could interchangeably call it AI4. So if you look at the first chip, this is the first time, hardware 3 was the first time that Tesla made silicon for inference. Prior to that, they used NVIDIA, and prior to that, they used Mobileye. And I mean, we're talking, many years ago now. I think 2014 was like Mobileye, and then I'm going to say 2016 timeframe was NVIDIA, and then they built this custom piece of silicon. So in around April of 2019, and then of course this is placed in all Tesla vehicles, and it runs around roughly 144 trillions of operations a second. I mean, that's pretty fast.
Mm-hmm.
It uses Samsung is the fab here, and uses a 14 nanometer node technology, which by today's standards is pretty old, and it runs around kind of fully taxed at around 100 watts of power. So that product today is in many Tesla vehicles. I can't tell you the count, but certainly all vehicles prior to 2023, except super old vehicles, have this chip. And today it's doing inference for version 12 of FSD. So then in January of 2023, Tesla introduced hardware 4. That's on all vehicles today. If you buy a Model Y tomorrow or a Model 3 tomorrow, you get a car equipped with hardware 4. This is a much faster chip. It runs around 500 trillions of operations a second. Also produced by Samsung at 7 nanometer node technology, and draws a bit more power. Not a huge amount of power, but certainly more power. And this is the state of the art chip today. It's the one that's in production. It runs inference for FSD version 13, and then what will be version 14. And I suspect that, and Elon has kind of confirmed in a couple posts that version 14 will fit on this chip. So, there's nothing particularly difficult. I mean, there's a lot of
Worrisome.
optimism.
Yeah,
Sorry.
no need to no worrisome, no worries
Yeah.
that this alone, if you've got this hardware 4 AI 4, it's going to be able to do robotaxi and full self driving at this point.
Yeah, absolutely. And the way you know that is, they were going, when they moved from version 13 to version 14 mile, they were talking about 4x number of parameters. And while it's not exactly linear in processing, you can think of as 2x the number of parameters is roughly 2x the amount of processing and inference per cycle. And then they suddenly announced that they'll be producing this version 14. I don't think they've actually called it version 14, but we've all called it version 14. That's 10x. And I made a post on that, and Elon kind of confirmed it, that certainly they leaned into a much bigger model, and that they feel they can fit it in a hardware 4 chip. And there's a lot of stuff that they do there. People are familiar that they take these models that are spun up using large precision floating point, and they quantize them down to smaller space, so that they're processing them with like integer 8 components or floating point 16, which means that this chip, which is smaller by size, can do the inference. And you have to remember that what inference on a vehicle is in FSD is, it's a process that's running at 15 to 30 times a second. So it means it's got to take in all the sensor data in one cycle, and run it through the model, and output a set of control values for accelerator, braking, and steering angle. And that's one cycle of inference. And this is happening 15 to 30 times a second on the vehicle. So they've obviously tuned the version 13 parameters and forthcoming 14 parameters for that. And today's Optimus that we see running around in prototype pre-production form is using hardware 4 chips as well. So now we're leaning towards a new chip called the AI5. This is a chip that's being built by Taiwan Semi, apparently using a 3 nanometer node process. It's much faster than our hardware 4 or AI4 chip. The AI5 chip is due in late 26. We know it to be a chip that's going to be 2,000 to 2,500 trillion operations a second in terms of its raw performance. I think it could be faster. I think Elon sort of indicated that. I think he's very happy with this chip. There's been several times he said that. He said that in the earnings call. He relayed that in several posts. It consumes a lot more power. So we're getting to the point where, certainly there's power available inside a Tesla vehicle, but obviously most of the power we want to use for the purpose of moving the wheels for driving. So I think flat out, it's maybe spec'd at around 800 watts of power. And certainly in the foreseeable future, this will be the inference engine for FSD and for Optimus. So I think when we see this, I think most production cybercabs eventually will have this chip. Certainly will have this chip as soon as it debuts, and obviously all Tesla vehicles. So then we lean forward. Yeah.
Yeah. So Phil, just a quick question here. Do you think that any product that Tesla is going to launch at scale is going to be limited until AI5 is launched? If you say it's late 2026, could we expect that maybe Cybercab won't be at scale until late 2026? Or robots?
I really don't know the answer to that. I think the way to answer that is I believe that hardware 4 or AI 4 will be sufficient for version 14 of FSD.
Mm-hmm.
So having said that, there's no particular reason why it wouldn't work in Cybercab any different than it would work in a Model Y or a Model 3, as a robotaxi platform. That said, I believe that Tesla will probably not reach full scale, full ramp of Cybercab until late 26 anyway. And I think this chip will probably meet it head on. So I think the timing will be coincident. I think if you were to see in the next couple months a few Cybercabs running around, for robotaxi or testing purposes, they certainly will have a hardware 4 chip in them. But they could have early silicon of AI5. I don't know when. I'm not aware of when they'll produce the first, batch of these chips. But obviously Elon has a good read on these. They must have some early.
Yeah, just wondering where you got the late 2026, because a year and a half ago, Elon said that he expects AI5 to be happening the end of this year. But now you're saying it's the end of next year.
I don't know. I don't. The good news is I don't think it's terribly material.
Okay.
I mean, I don't
think
AI
AI4 works.
Yeah, I don't think it really holds. I don't think it holds Tesla back. But if they do, if it's an early 26 release, great, more power to them. And then obviously every Cybercab would be equipped with that chip. But yeah, that chip will run us from whenever it's released, sometime in 26, until AI6 replaces it. Right. So now AI6, we talked earlier, when would this chip show its face? And probably 28 or 29. I don't think we'll see that in 27 at all. What kind of headroom does it have over, say, an AI5? I think significantly. It may be 10x, it may be actually more. The fact is that we don't know much about its architecture, and we don't know much about how far along it is. And I suspect it's not far along at all. I think it's just been outlined sort of more, these are the features we want. This is what we're trying to do with this chip. Here's what we're going to draw on from our early experience with Dojo's D1 chip and our experience building these inference chips. Now, this is the chip that Elon's talking about. This is the convergence chip. And this chip, will be built by Samsung. We're back to Samsung. And I think a 2 nanometer node technology, I think that's what they're leaning towards. And of course, this chip then is the convergence chip. It will do inference for FSD. It will do inference for Optimus. In other words, we'll have 2 of these chips in every car. We'll have 2 of these chips in every Optimus bot, possibly more, but probably 2. And then it'll be architected in a cluster model for training, data center use, and inference, I might add, because remember, it's possible that this chip will make its way, over to XAI as well, and not only train, the next great, Grok model, but also be involved in a lot of the inference as well. Ultimately, in a sense, replacing or at least augmenting their NVIDIA build. So, that's what we have to look forward to.
Nice. Great. I love this table. Excellent. Teaches us a lot. Appreciate this.
Yeah, so let's drill down a little bit on this evolution from Dojo's D1 to this AI6 chip. on the left side here, we're talking about D1 specifically. So D1, very clever architecture here. This is obviously the chip of the current Dojo. If you look at the circular object below, that represents a wafer, silicon wafer. That's the kind of raw material used to etch these chips. And you can see that I've shown it as a 2x2 grid of 5x5 chips. So what I'm saying is, and I'm not absolutely certain how this is cut out, and to be honest, it's kind of irrelevant. But we do know that a tile in Dojo land is a 5x5 set of D1 chips, and they're not independent. They have interconnects between them, so they're not just literally sitting there. That okay, let's just organize. No, they work as a unit. Kind of as this 2D matrix of interconnected chips. And what they then do is they cut that out as a tile. And that means that within that tile itself, the yield has to be 100%, right? So typically the way you think of chips is that you create a number of chips on a silicon wafer, and you cut these chips out, and these dies are individually tested. And the way you might do it at you might test them at a certain speed rating, and those who make that rating of let's say it's a 4 gigahertz or and then some chips won't make the cut, and then you test them at a lower rate and they might make that cut, and then maybe you're trying to bin them in 3 ways, like 4 gigahertz, 3.6, 3.2, and then some chips won't pass at all. You just throw them in the garbage. So there's a yield that occurs. There has to be a very high yield here because you need the 5x5 grid to be intact. But again, this is a specialized computer. It's not like Intel selling, millions of chips here. And so they call this effectively a system on wafer design as opposed to a system on chip design. And then what they do is they take these individual tiles and they layer them together in what they call a cabinet. And that becomes the Dojo computer. So D1 itself as a chip, it's a little bit different than the AI6 chip, or at least what we think the AI6 chip will be. It's really, really focused on getting a lot of data through. So it's more bandwidth focused than speed focused. And obviously, it's super fast, but on the vehicle, we're looking for reducing latency, between the time we receive data, photon to control latency. But in the data center, training isn't really that sensitive to that. It's really focused more on the bandwidth side. And this chip, as far as I understand it, maintained these individual math cores. So to understand what's happening here is inside the chip, the chip is not uniform within it, inside it has different component pieces. And part of it is it has little math cores, things that compute. And these are known largely as like floating point cores or integer cores because they do like floating point math or integer math. Okay. So something like D1 is focused on floating point 64 or floating point 32. That those numbers mean the number of bits that represent a number. In other words, really big floating point numbers, right? A floating point number is like 123.6, whereas an integer is just like 123, right? The training process needs a really high fidelity kind of expression of the numeric set. So it uses floating point for the training side. And so this chip was really optimized in its math cores for, high precision floating point numbers like 64-bit and 32-bit. Those are very big numbers if you kind of work it out. Now, the i6 chip on the right-hand side here, its focus is more on reducing latency. In other words, it's trying to get the compute cycle or whatever the operations, say matrix math operations, through the chip as quickly as possible, noting that you wouldn't have as much coming at it. That's a funny way of saying that. Obviously, these are very big data structures that are coming through. These matrices are coming through, but the AI6 is really, really sensitive to trying to reduce the latency of operation, right? To getting reasonable data through as quickly as possible. And they do something really, or at least I think they're going to do something different here. They're going to use what is called a generalized block quantization method. Now, it sounds really techie, but what they're doing here is they're saying, hey, this chip can switch between floating point 64, 32, 16, 8 dynamically without maintaining separate math cores for these operations. It has a way of switching dynamically. And what it does is it pulls together a block of data and runs it through whatever size floating point operation it needs to. So sounds pretty technical, but what I'm saying is what you do in training, let's take FSD. What you do in training is you train the data with, say, floating point 64 or 32-bit numbers, really big, high precision data sets. You then go through a process called quantization that downsizes these numbers to a smaller number space. It's like a mapping. You take a number set up here. If you want to think of it as simple terms, although it's not done this way, in simple terms, it's like rounding the numbers down or something. Like you're saying, well, maybe the number was 123.6421. Okay, we just want that to be 123.64. We'll forget about the thousandths place and the 10,000ths place there. They don't exactly do that. Quantization really takes a number set of high precision and maps it down to a smaller number set. And yeah, guess what? It's lossy, right? You lose data there. You can't go backwards. In other words, you can't, when you quantize like a model, once it goes through that process, you can't reverse it and get back the original model, the trained model, because it literally has lost precision. But it's okay. And this is how they fit these models, these high precision trained models, in vehicles like ours today using an AI4 chip. They quantize down to maybe just integer math. And while it's kind of techie, it kind of explains one of the massive performance optimizations that occurs between training and inference, is that quantization process. And with this particular chip, the AI6, what they're saying is, you know what, we're going to produce a chip is a generalized architecture chip, right? It does inference very, very well, but it does training very well. Maybe not, super well, but it does training very well. And that is because by using this methodology that Tesla has a patent on, they will dynamically shift the way that they send data to it and how they want to compute it through this idea of whether it's like 64-bit floating point numbers or 32-bit, 16-bit, et cetera, et cetera. So what that means is you have a chip that's awesome for inference, which will be, hugely utilized across Optimus, FSD, and of course, any other inference processes, like maybe just asking Grok questions if the chip gets utilized in for XAI as well. And while it's awesome at inference, we'll see it being well utilized for training as well. What they will do, Herbert, is they will design it to be more of a cluster design, where they'll reach for we'll have we're back to individual chips, dies cut from the wafer. We're not looking at the tile architecture, and then they're put on a board where it's sort of a cluster of chips that operate with a software layer on top. I think and this sort of will be effectively in spirit called Dojo 3, right, for the training side. And Elon kind of referenced that name. I don't know if the name will persist, but yeah. So there's a lot there, but I think that's what's happening here is we're moving from a chip that was purposely designed for training, for moving a lot of data and not super sensitive to the latency, to a chip that
And
is general purpose.
Tesla can continue using the NVIDIA chips that is purposely designed for training anyway, so they'll just keep doing that. And I think the focus of Tesla decides to do is let's create our own inference chip that can also do training, but it's not like we're losing something because we'll keep buying not only NVIDIA's, but other manufacturers will make the training chips.
I think at the end of the day, with respect to, look, it comes down to this. If you look at it and you're trying to build a training system, you're building a coherent cluster of many, many different chips, right? I mean, even no matter how many NVIDIA chips you get in a compute box, you have to arrange hundreds of thousands of them to act coherently together for training. And that's a crazy hard thing to do, right? I mean, if you look at the Colossus Training Center in Memphis, that's known as, I think, the largest coherent training cluster in the world. And there's, I don't know, 300,000 NVIDIA GPUs there that are probably a mix of a couple flavors. But the fact is, these things are operating as a single compute fabric for each training cycle, each epoch of the training cycle. And ultimately, it isn't super important that happens in 100 milliseconds or 200 milliseconds. It's just important that it happens cohesively. So if what Tesla ends up with ultimately is they have a training chip that's slightly slower, then all that really means is that they just deploy more computers, right? It's not more than that at that point. But that chip from an inference point of view will be super fast. So you're left with the best of both worlds. There's not perfection here because there's differences in how training and inference work, but you're really left with the best of both worlds with AI6. And that's, if you get over all the technical jargon that we've talked about, that's what's happened here. Dojo was very specialized. It ran its course. It was really a training computer, and time has moved on rapidly, and inference has become more and more pressing and important, and we'll start to see training happen on the edge, meaning like in the brain of Optimus itself. You kind of at that point you say, let's not like invest another couple $1 billion in the next 10 versions of this chip.
Yeah, I think X and XAI should be the one to build the training compute and the chips instead of buying it. They can do both, of course. But Tesla, as a Tesla company, we need to control our future for humanoid bots and cars and mobile devices. Anything that moves needs to become autonomous. And this will be way more than just cars and humanoid bots. It'll be any form factor you can think of will be made by Tesla, and they need 2 chips each. And you don't want to be, restricted from buying these things from somebody. You want to be able to create it yourself. So yeah. I absolutely am happy that Tesla is focusing and saying we're going to be doing. They already were. They were already making an AI4 and AI5.
Right.
But now that they're going to just double down on it, and like you said, doesn't make sense, Elon said, to have 2 chip architecture. So I think that if Tesla focuses on the inference, XAI should be focusing on the training chip compute.
Yeah, I mean, I think, at the end of the day, here's what's true. What's special is what you point out is the actual use of this chip, the inference side of this chip, is where Tesla needs differentiation in terms of price, performance, power, all those components. So to build the chip there, to focus on that, is where they should put their attention. If Cortex, which is the training center today for FSD, and I'm sure somewhat for Optimus, were to just exclusively stay NVIDIA for the next decade, it's really immaterial.
Yep.
right? It's immaterial. It doesn't really matter. NVIDIA produces an amazing product, and Tesla is perfectly excited to buy the product. And there's nothing that says that they can't continue to buy that product. And it's clear that they already know how to build a hybrid architecture, right? Because some of the training in Cortex today is done by the current version of Dojo. Whether that's 5% or 10%, it means that they're also another coherent cluster, which is the Cortex one for training. They've learned to use mixed architectures, right? They're using different, potentially different generations of NVIDIA chips, and they're using Dojo. And if you think about it, that means something quite dramatic. It means that the software layer on top is all Teslas, right?
They're doing a lot of heavy work, yeah.
Yeah,
To be able
because
to take whatever chips, chip agnostic, yeah.
Yeah. And so the lean in here is focus on inference. It's where you have the most quantity, the most differentiation. It's where Tesla should be. And
the Dojo would have saved Tesla 70% of margin that NVIDIA marks up their chips. So it would have saved them a lot of money.
Right.
But on the other side, if you can sell more bots, then you can make more money.
Yeah.
So you could pay for the cost of chips on training side.
I think it would be very.
Yeah. On the bot side,
it would be hard to compute the marginal cost for per item using NVIDIA. Meaning, like if you're talking about, we have a billion bots running around, and the principal model was trained on NVIDIA. Does that add 10 cents a unit? I don't know. It's something immaterial in the end of the day.
It's immaterial. But the amount that inference can deliver you, because if you have the better inference chip, this bot can work 3 hours more than the other inference chip because it doesn't use as much power.
Yeah,
it can do things like, you throw a ball at it, it can grab it because of how quickly it can move versus other bots won't be able to do that if they don't have a good performance latency in their chips.
I think you distilled it down to the most important part here, which is that what Tesla wants to do by controlling its own destiny, it can very deeply integrate its software and hardware side here, right? So that the outcomes that you talk about, like very low latency. And so if you have very low latency inference on FSD, that means instead of how about this? Instead of running maybe 15 cycles a second, you can run 60. What does that mean? It means the car's safer because it's perceiving the environment 60 times a second versus, say, today at 15, right? That's one difference. To your other point, in something like Optimus, you want to achieve the best performance for power. You're going to have maybe a 20 kilowatt hour pack in Optimus, and then you can basically say, okay, well, let's really organize how we do this. Remember, what's important to understand here is that while we talk endlessly about the fact that Tesla produces, like for example, an FSD. We talk endlessly about the fact that Tesla produces version 13. They pop it in the car and it goes. That's not how it happens. They take that model, they do that quantization process, and then the software team gets to work, like from an embedded systems point of view, and works tirelessly to squeeze every ounce of performance, which means get the best cycle time for inference, get the lowest photon to control latency possible, because that equals safety. Ultimately, that equals safety. So that team works a lot on that problem, and it means that they're shoehorning the model into the current chip architecture to make it work effectively. And at the end of the day, this is the beautiful advantage that Tesla has in completely vertically integrating the stack. They are producing their own hardware for their own software, and that's just a beautiful thing. And how do we know that? Because every product company in the world that does it that way produces great products at great margins, Apple probably being the one that's most noteworthy.
Great presentation. Learned a lot. This is something that a lot of people have been asking to learn more about. AI6 is arguably could be the most important product that Tesla is making today. That it's what will It was what will run every other product that we can think of. And I'm glad that Tesla's doing it. So follow Phil on his X account, PBEISEL. And he's got all these deep dive articles that he writes. And then he just obviously did one here. This was old, right? You wrote this accelerated
That's
computing.
old, but very pertinent to this discussion. And I put the nice fat arrow there to say that if readers want to understand the guts of this whole area of accelerated computing, which is all about inference and training, this paper goes pretty deep, and it's a lot of fun to read. It may take a couple reads, but it really, really draws out what the heck is going on inside these things we call GPUs.
Yep. You got to learn this. This is the new language. You can't get away without knowing this information at this point anymore. This is the future of AI.
Yeah. I think it's super important. I mean, you can use products without knowing the guts of the products, but we're not in the days
of... Well, if you're an investor of Tesla, no, you need to know this stuff.
You should know what differentiates Tesla from the others and their material advantages. And I think, I can't emphasize enough how important this whole AI6 is to Tesla's future. And to your point, Herbert, it's every edge device that Tesla produces from this day forward will have this chip. Every edge device. Any device that they produce, this will be in Tesla Semi, obviously, for purposes of FSD. You can guarantee it'll make its way into Megapack and other products as well, because everything software is moving very quickly to AI, and AI needs these chips to operate. So
I'm predicting it's going to be much more than just a vehicle and a robot. It's going to be every product you can think of. Tesla can make a security camera. They can make a drone. They can make name any device that moves.
They make a drone.
Put a camera on it. It needs a chip to know what to do, and then all of a sudden it becomes intelligent. This becomes an intelligent animal. Anything can happen. Let's say you're whatever. You can have you can buy a whole new an iron that actually can move and do it on its own. Magic iron.
What we've done here is we're moving from, we moved from the place where computers and then smartphones had these powerful chips, which we called CPUs, right? And then we've ended up with an explosion in the recent years of what we call Internet of Things, meaning everything in your house has some CPU in it, right? Like a dishwasher or refrigerator. Some use cases seem completely silly, but every product in your house now has small ECU, which is some small microcontroller. It's basically, they're all a bunch of ARM processors running around, right?
Take a look at this thing.
Yep, it's there. It's
a smart outlet. It's got a Wi-Fi in it. It's got, it's got a little tiny chip in there.
Pretty much anything that is powered or battery powered has some kind of microcontroller chip in it, some CPU. And where we're going is the same reality is happening again, where every single device, no matter what it is, will have one of these AI inference chips in it as well, accelerated computing chips. So, I can't sit here and defend the dishwasher use cases, but I guarantee that, 2 years from now or 3 years from now, one of these inference chips will sit there in that type of product as well.
Thank you, Phil. Follow him on his X account. Appreciate you so much. Bye-bye.
All right.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.